Hey guys, today I will show you how to find all integer numbers satisfying a compound linear inequalities. Say you have been given these two inequalities and you need to find all integer values of x satisfying or that work for your compound inequality. So basically, first of all, you need to solve these inequalities. So you have two inequalities and you need to solve them simultaneously since you are given this and. All you do is just solve them separately down below, and after we need to come up with the common solution, set that satisfy that work for both these linear inequalities. So first of all, let's start with the first one. So you solve both of them normally as you would do a normal linear inequalities. And by the way, if you need extra help with solving linear inequalities, I have a separate videos and I have a bunch of videos on solving linear inequalities. The link would be down below in the description box, and if you are down to this, you could jump into this and check it out later. Now, typically you want to collect your x terms on one side of your inequality and your numbers or constants on the other side. So since you had this -2 next to 3x and you basically were aiming for x, we want to kind of isolate your x, we want to get it kind of alone. So you want to move this -2 to the right side by adding 2 to both sides of your inequality. So you want to move 2 to this side by adding 2 to both sides. So you end up getting, so bring down this 3x at this point. So it becomes 3x. Now 2 and 2 goes away, bye-bye, it disappeared. So bring down less this inequality sign, and 40 plus 2 gives you 42. Now, you want to isolate your x. Whatever attach your x, so in this case it's 3, divide through both sides of your inequality. So also keep in mind, what you do to one side, you have to do to other side of your inequality. Keep it balanced, so you don't want to change the overall value of your inequality. So you divide by 3 both sides, you divide by 3. 3 goes away, disappears and drops out, so you would be left with x less than, so 42 is divisible by 3, so you end up getting 14. So x less than 14. So this is the solution for the first inequality. We are not done yet. So in the same way, likewise, we have to solve the second one. So, and it's basic, again, it's basic. It's very similar to the first one, linear inequality. So you want to move this -18 to the right side by adding 18 to both sides of your inequality. So bring down these 2x at this point. So bring down these 2x at this point, so you are left with 2x, so 18 goes away, drops out, so bring down greater sign, and you are left with 18 on the right side. So again, you want to isolate your x, so divide both sides of your inequality by 2 in order to get this x, and your x is greater than 9, since 2 fits into 18 9 times. So x greater than 9, this is basically the solution set for the second inequality. And keep in mind, for the inequalities, for all inequalities, the solution, so when you solve it, basically you come up with a solution set. So basically it's infinite set of numbers that work, that satisfy for your inequality. Now, basically what we can do, we can join these two solutions since we are solving this compound inequality. So we have this Conjecture. Does this work? Does this word exist? Conjecture. Let me look it up.
Conjunction.
Okay, conjunction. Here where? Okay. I was looking for this word. This conjunction. So we can join these two solutions and we could write it in a one. So your x basically has to be less than 14 but greater than 9. Alright. So at this point, this is the solution set for this compound inequality. Now, we need to find all integer x that satisfy that work for this compound inequality. And by the way, as a quick recap, so integer numbers that basically 1, 2, 3, 4, list goes on forever, keep going. You throw in 0, it's also an integer number. And also all natural numbers with the opposite sign, so negative numbers. So -1, -2 also are taken as a integer number, so also considered to be an integer numbers. So basically we can pull out these integer numbers. So all integer numbers that satisfy these compound inequalities is gonna be, so all integers is gonna be, so first of all 10, 11, and we can list them out, we can make a list, 12 and 13. That's all. Notice that 9 and 14, they don't work for this inequality. They are not solutions, they are not roots, so they do not belong to a solution set, and also they are not that integers that work for this compound inequality. So it's going to be only 10, 11, 12 and 13. Well, before we dive into the second one, as a quick pro tip, so for all of these problems, what you could do, if it helps you, you could draw a number line, you could place your solution set on a number line, and you could basically figure out a solution set, these integers, you can pull it out from a number line if it helps you. Basically, I do have a similar video on how to find a smallest integer number, a smallest integer value for x that satisfies a linear inequality, and the link to this video will be down below in the description box. So the problem, basically, it's very similar to what we are doing now. So basically, it's similar. It's different, but it's similar. It's different, but it's similar. Since there you need to find the smallest integer. So, and if you are up to this video, the link would be down below in the description box and you could check out it later. Now, say you have been given something like this. So similarly, likewise, you want to first of all solve these two inequalities separately down below. Let's solve them separately. So for the first one, you want to move this 16 to the right side by adding 16 to both sides of your inequality. So you add 16 to both sides. So you end up getting, so bring down these 3x at this point. 16 cancel each other out, so it goes away, disappeared. So less than or equal, bring down this inequality sign. 16 minus 10, that would leave you with 6. And again, you need to isolate your x. You need to get your x alone. So whatever attach your x in this case is 3, divide through both sides. So 3 goes away, 3 drops out, bye-bye. It disappeared, so you end up getting x less than or equal, since 3 goes into 6 twice. So the solution set for the first one is gonna be x less than or equal to 2. Alright. Similarly, we are going to solve the second one. So looks a little bit messy, since your terms, your x terms, your numbers, they are kind of scattering around. So you want to group them. You want to collect the x terms on one side of your inequality and your numbers on the other side. So I'm going to bring these 2x to the left side by subtracting, by taking away these 2x from both sides of your inequality. So remove these 2x from this side and subtract it from that side. And simultaneous that one goal, I'm going to move this 8 to the right side by subtracting as well this 8 from both sides. So minus 8 minus 8. So you end up getting 5x minus 2x. So we are left with 3x. Now 8 goes away, dissipated, drops out. So drop down the equality sign, so greater than or equal to 11 minus 8. So that gives you basically 3. And finally the last step. So you want to divide both sides of your inequality by 3. So in order to get your x. So 3 goes away, disappeared, so you end up getting x greater than or equal 1. So that's the solution set. So all these x's that satisfy that inequality, that's gonna be your solution set for the second one. Now, similarly, likewise, what I did before, I want to join them into one solution set. So your all x's is gonna be less than or equal than 2 and greater than or equal to 1. So this one is going to be the solution set for this compound inequality with this conjunction. Yeah, that's the word. Is that conjunction? I never remember this word. I don't know why. Never. What? Conjunction. Conjunction.
Conjunction.
Conjunction. Conjunction. Conjunction. Okay, I have a homework to learn this word by heart. I promise you. Okay, conjunction. Now, this is a solution set to a compound inequality. And what we need to do, since we are looking for all of integer values of x, all of integer numbers that satisfy, that work for the inequality, we are going to pull them out. So look at this inequality, look at this set basically. So we have only two integers that basically work for this inequality. It's 1 and 2. Since 1 and 2 both belong to this solution set, and between you don't have any other integers. So all integers, it's gonna be just 1 and 2, and we could write it down. So all integers, so all integers is just 1 and 2. And that's gonna be the answer for that problem. Again, at this point, if it helps you, you could draw a number line and you could represent your inequality on your solution on a number line. So let's go through this quickly. So you have 1 and you have 2, and all your values of x, they're going to be between. And look at this number line. So since you have no integers except this 1 and 2 between, so I mean the proper integers, so there is no integers between, so the integers that only work for this inequality again, so it's gonna be just 1 and 2. Alright, with this being said, I hope it has been helpful to you. Huge thanks for watching, and anyway, I know everyone hates math, but if you like my video, please hit this like, share with your friends, leave the comments down below, and be sure to smash that subscribe button if you haven't, so you'll not miss out my new videos.